what a day! What a lovely
Welcome
day!
to the Flat Earth Debate Live. I'm your host Nathan Oakley, and if you are new to this channel, or you've not done so already, then be sure to subscribe. Hit the bell notification icon and join button if you'd like to become a Nathan Oakley 1980 channel member and keep up to date with the Flat Earth Debate. If you would like to support the channel, there is a super chat that runs alongside each of these shows while they are live, and there's also a Ko-Fi, Patreon, crypto and thanks button in the info box below the video. Most importantly, if you'd like to join the discussion, simply mute the page you are currently watching, then click the link in the info box below this video to join the panel and express your views on the nature of Earth. If you do join, please don't swear. If you do, you'll be ejected, and if you are, please don't try to rejoin the stream using sock accounts. You'll be warmly welcome back on the next stream. Please also share the show on social media. Sharing the show obviously increases the live audience, but this in turn increases the chances of a more diverse panel, so please share the show on Facebook and X. Now, we are joined by Eli, Refracted, Neil, and a whole bunch of people in Discord, so welcome one and all.
How are you?
I'm good. How are
Hey.
you?
Good morning, good morning.
Good morning. Good morning, good morning.
Good morning. You wanted a warm up, you got one.
Yeah, well,
I was going to say the same thing. He extra warm up. Boy, you got us heated.
over the last couple of years, since 10th was going through celestial navigation, maybe 3 years, there's been various different diagrams that I've tried to bosh together to try and describe the concept that Lumpy was asking about. So in my mind, I can visually describe it without having any of those diagrams, having made them. So the diagram that I'm picturing is a little stick man standing on a flat plane, measuring an angle to a sky that's above him and parallel with him. Now, when you draw the line through his position to the sky, that forms an angle with the ground, right? Well, if you draw a protractor around that position, obviously the angle that you're measuring, the star in the parallel sky that's above this guy, this stick man on a flat plane, his angle will pass through the protractor. Now, if you imagine that that protractor's actually a globe, and you're in hell, then this works on the equatorial plane in hell. And obviously, they would say that we're doing it on the globe surface that is actually the protractor. And because all light runs parallel and it's so far away, you might as well treat it as though it's inside the globe when they pretend to measure angles that you can't get from curves. So that is the full summary of how a measurement of a flat plane to an angle of a star that can only take place if you have a parallel sky with a flat Earth is then described with a protractor being the globe. Now, the measurement must and does and will require the flat plane that is described inside the globe at that point. That's called the equatorial plane. And the dome of the sky is another representation of the angles that you would look through if you put a second protractor through the positions that line up with the sky. But ultimately, to have this protractor-based system where you're drawing angles to the stars in the sky off a flat plane, you must have a parallel sky and a parallel flat plane. That's how this works with the stars when you measure angles to them. Now, those facts are slightly convoluted when you get to the fact that the angle doesn't change as you raise in elevation, which is, not to put too fine a point on it, bizarre. It's weird. It doesn't behave like other things that we would measure, like a skyscraper. If you're far away from it, you measure an angle like it's a star. There's a little blinking light on the top of it, and you measure it as though it's a star because it happens to be in the sky like the stars are. But as you raise in elevation to the skyscraper, the angle decreases. The angle lessens until you get to zero when you're parallel with it. Now, that is not how the stars behave. You raise in altitude and the angle remains the same, meaning that you can have parallel lines to reference in the air with things like bubble sextants and still get the same angle to the star, and it'll match in the almanac with the ground position at a certain time. So if this does lead to confusion when you've got a globe belief, because somehow you've got to insert a globe into that rhetoric. Well, if you can back engineer the elevation angle measurements to Polaris with a Polaris-centric system, then you can wrap those areas of equal elevation, that would be declination points of the star Polaris, to the horizon as you back away from it. those circles that you draw off the flat plane with the angles that you've measured can then get wrapped around a ball. Now, that means that when you take the measurements in the equatorial plane in hell, they do back engineer onto the globe as positions that you rotate. So when a globe describes 1 degree for every 60 nautical miles, they're rotating a protractor, not measuring an angle from a surface. Who's making that bloody noise? The noob. Did you want to add something? Sorry, I shouldn't get so stroppy. Did you want to add something, the noob? Okay, Pink Panther.
Sorry,
That's okay. The Pink Panther on screen now is what you try to acquire these angles I've just described with declining measurements towards the horizon as you back away from Polaris. You can't get angle measurements from a curved surface, and the globe itself will take place on the equatorial plane because that's what they've back-engineered the globe as a protractor that you're not actually standing on to work as the protractor. The angles as they decrease as you move along a flat plane are representative of a turning protractor that they call the globe. Well, of course, as we move over the curved surface, we get 1 degree of the turn of the spherical surface that is actually now a protractor that you're standing on. We're not. But that's how this back engineers into an actual reality that we can measure with a flat plane beneath our feet, and that is how we do measure Earth. That was a good little ramble off the back of 4 hours of discussion with lumpy gas in a vacuum yesterday.
Well, I would point out to anybody that's argued this subject to go back and listen to any argument that they've had where their opponent has made a positive claim, and it will always involve an elevation angle to the stars, without doubt or exception.
I've got any of my mods in the divergence there. I can't remember who it was that sent it me. Somebody sent me a link to Dave McKeegan with enough information in the thumbnail for me to know it's a video worth covering, because his statement from the thumbnail, from what I glean about the video, is that he's saying the equatorial mount can't work on a flat Earth. This is going to be another Triangles McKeegan moment, because they can only work on a flat Earth, but it'd be interesting to see how he describes it, because I'm sure there'll be some flat Earth proofsies in there. So if one of my, I couldn't seem to copy the link from whatever media platform that the person sent it to me on. I couldn't seem to get it into YouTube to be able to grab the link and stick it in Skype myself. But if someone can grab that Dave McKeegan video, I believe it's a recent video. We'll cover that today, obviously, and let Dave know that we're covering his video. Help him in the algorithm and all that stuff. I'll send you his way to let him know at Nathan Oakley 1980 sent me. Hopefully someone will stick that in Master B. In the meantime, we'll ask the most relevant and appropriate housekeeping question. Any evidence that you can acquire an elevation angle measurement from a curved baseline? On screen now is an elevation angle measurement.
Well, on screen now, I don't see a curve.
You can't have it be curved. You're talking about angle measurements. It is with respect to a flat baseline and a ground position. With respect to this star on screen, that's how it's measured. You have to have a flat Earth to measure this in the first place. That's how it works.
Then it's game over.
But now imagine that you wrap a protractor around this position. So if you say here's the GP of the star and it's relatively close to you, and then extending out beyond the frame of this picture, you've got the start of the protractor, and the protractor goes all the way around and down. Well, you can then suggest that a star that was up here with an angle going up like this is represented by its point on a protractor. Yeah? Then you can say that protractor's the globe Earth. That's how they've done it. That's how they've tricked us with actual measurements of a flat Earth that we deal with and dwell atop. That's how they've turned it into a spherical surface that we're not actually standing on, but still back calculates with angle measurements that always were and always will be flat Earth measurements, like the one on screen. But, as I was describing to Lumpy in the pre-show, for this to function, the sky and ground have to be parallel, and by whatever virtue of God's command, they are, regardless of your elevation when you measure them. That is, the angles to the stars remain the same at all altitudes.
But what if I could get higher? I mean, really, really, really high.
we do, and they stay the
That-
same angle.
Oh dear.
But as I said earlier, that's not expected behavior. If you think the stars have got some physical attributes that are akin to the tangible physical items that we encounter in our day-to-day lives that we can go up and touch and measure and verify their height with angles and trig. Well, this isn't trig. When you're talking about celestial navigation, what you see on screen may be a triangle, but it isn't trig that you're performing for the reasons just disclaimed in terms of the behavior of the star itself. You can't calculate the
And
opposite.
that's what everybody struggles with, right?
I don't know if people struggle with it. I didn't struggle with it. But perhaps people do. The way that the stars behave is what it is, you know, and the fact that it has a very useful and practical application for navigation that is exploited by us and has been exploited by us to the point where we can exploit those facts and turn them into spherical protractors wrapped around us is amazing. You know, it is the majesty of the heavens. Arguing about why it does that seems pointless to me. It's along the same lines of trying to figure out the cause of entropy, in my opinion. Why do the stars not change their elevation angle measurement with any elevation that you are at? Why doesn't the elevation angle change with elevation? It makes no sense. No, it doesn't. Nevertheless, you can be at 30,000 feet or at 0 feet and measure the same angle to that star. Why? I don't know. But you can still find the position below it on the ground with the almanac, because we know the pattern of the stars and where they'll be above. Very useful.
Question. In chat, Gary Wabanga, he is saying angles to the stars will change with elevation if you're using a marine sextant.
No, they
I
won't.
don't think that matters myself because
No, they won't.
level is level.
No, they won't change. That's incorrect. Saying the angle will change if you're using a particular type of angle measuring tool. No, it won't. Flat out wrong. But, I mean, if somebody wants to demonstrate that to me, then feel free to violate the very solid principles of celestial navigation, because that's what they're arguing with when they defy a principle that's employed in this regard. Like, okay, well, you're just arguing with celestial navigation if you say that it isn't the case that they remain the same angle at all elevations. They do. The stars, that is. Go on, Neil.
It's so rock solid that I thought I heard Adam asking yesterday, is it natural law? I mean, because they do the same thing all the time, right?
Yeah. I mean, that principle that you're describing with the parallel plane of the sky and ground remaining the same at all elevations when measuring stars, that is something that occurs always. Ergo, Adam's intonation that it could be, in some way, described like it's a natural law. And you could go, yeah, I agree. That which occurs always is natural law. Does it always occur that the elevation angle measurement to a star remains the same regardless of your height above the ground? Yes. So could you therefore accurately describe that as a law of nature? The star's angle will remain the same at all altitudes. That's a statement of law when it comes to nature. Inviolable. Did Adam really speculate that? I do vaguely remember. I was probably losing at Fortnite at the time, so I wasn't paying too much attention.
Yeah, he did. And it is amazing when you think about it.
Amazing and useful, but stupid to argue with. So when you get people who contradict fundamental aspects of celestial navigation with us, it's just laughable. It's like, this isn't a up for debate subject. If you want to disagree with how celestial navigation is functionally operational, then you be my guest. But that seems silly. It's not a claim I'm making as a flat earther. Earth is just measured and navigated flat and dealt with flat, and that's how your globe comes to fruition. So to deny that is to deny how the globe has been functionally put into operation, if you want to claim that it is operational. It isn't. It's functionally flat and then reified into existence by numpties who've taken orbital motion from people like Kepler and Huygens and said that that means we're standing on a spherical surface, just so that we can have what the church's better ideas of how to track the motions of these stars by describing them with orbits. It's ludicrous. Notice John has vanished now. All the passion and gusto in the pre-show. Check it out if you're a member. There was a fairly heavy discussion between John and Lumpy Gas in a Vacuum. And indeed yesterday for the members. Although I did release that to the public just before it finished.
John goes up a couple of octaves when he gets upset. It's funny.
Don't blame him. We've got people who don't understand it. No offence to you, Lumpy. That are, in essence, debating us about it. And you're like, okay, it's obvious that you lack a comprehension about what's being described. And from my perspective, when I'm listening to those arguments, John's frustration is born out of the fact that why are you challenging this if you don't fully understand it? So I can understand his frustration. But by the same token, it is complicated. It has taken me a significant amount of time to fully understand it. Nowhere near as complicated as Coriolis. It is easy enough for most people to understand with a little bit of description. And as time goes by, my poor diagrams that I use to describe the semicircle around your position, then described as a globe rather than a protractor or semicircle over your position that you've just got the angles from, that will become more and more refined so that people do understand how the flat Earth is a requirement. And the more that we discuss this, the more it becomes prevalent in my mind why we haven't been eradicated. Yeah? There are certain far extreme groups that can just be eradicated from YouTube. Same with medical disinformation. Just turn it off. If they breach this line, turn them off. And they can do that. Why aren't we in that position? Because as much as we bleat and moan about censorship, we're still available. You can still share this show. If you're watching right now, you can click on the share button and stick it in your friend's feed on Facebook. Suddenly they're exposed to Earth's measured flat. Well, why can't YouTube just score a line through us rather than under us? Well, the reason is simple. The globe religion is based on flat Earth. You can't just eradicate something that's a fundamental foundation of a globe idea that is part of a Western world religion. If it's fundamental to the foundations, you can't completely eradicate it. We will be here forever. We are beyond censorship. So when people ask me questions like, well, why don't they censor the celestial navigation people? Well, because in reality, it's the other way around. Why aren't they censoring us completely? Because they can't. Because the basis of the celestial navigation being described by the people who don't suffer any censorship when they're just talking about how they get angles from flat planes with stars for navigation, the basis of the globe religion, those flat angle measurements to Polaris specifically, why aren't they getting censored? Well, they can't be either, can they? They're just factually describing something like navigation, and so do we. So what needs to happen? Well, you need to steer the reality of a flat plane measurement into a feast of nonsense garbage spiel about ice walls and domes, so we can mock the people who say what is true when they're not really alluding to anything that's factually accurate in terms of measurements. Now, we've come under the most fire, or I personally, I'll correct that, have come under the most fire ever in 10 years over the statements that we're currently making about Earth being measured flat. Smash that share button if you haven't done so already. If you've got some passion about this, this should be the thing that instills the passion. And if you're watching from the sidelines going, wow, he's catching a lot of flack. Yeah, that's because we're really at the point where we're not disseminating anything that can be mocked. And when we come to contest it with mostly our own bloody side, I might add, it's because of a lack of comprehension of something that is very simple. We're just measuring a flat Earth. The angles that came from Polaris gave you your globe. And that might be lacking enough information for most people to wrap their head around if they've only just arrived here. But those are the facts of the matter. Hence, we are above censorship.
I would say that if anybody is struggling with it or don't understand, we were privy to 10th Man coming in the pre-show for about a year, leaking this information and teaching us this. Go back and watch some of them videos. They're really good.
Yeah, I
I
agree.
mean, we still got them all, right?
Yeah, this show represents a timeline of our discovery through this subject matter. You know, there's a good chunk right in the middle, Refracted's on the panel right now, where we actually witness a transition, where it's like day one of being a flat earther. Here's how my mentality currently stacks up, and over time that's faded because John's become a flatty, and obviously he's not. You can't retain a non-flat mentality once you've recognized it. You can only remember and recall how your mentality was prior to a particular moment. But all of that got shared while it was fresh in John's memory, while we were going through the starting points of some of these arguments with 10th. But it just, like I say, the whole show, the thousands of them, represent a journey of discovery from flat earth garbage, feast of nonsense, controlled opposition rhetoric that we were fed when we arrived, through to us saying, that's just how Earth's measured. It's flat. For your globe faith to exist, that must be the case. Otherwise, we would have just been disappeared. But we can't be, and why? Now we know. Because it's a fundamental, foundational premise that must be in effect for you to claim you're on a sphere, as ludicrous as that reification is. Amazing, isn't it, how far we've come in 10 years?
They need a flat plane more than we do.
Yeah. To make their sphere claim, they need a flat plane more than we do. We don't need to assert anything that is beyond the obvious and observable nature of what we actually deal with. And for every example that we get presented that's a measurement, it'll be have an apologetic for why it's not globe-shaped attached to it. Now, prior to now, we've not recognised that saying it's so big, that's why we measure it flat, is just, that's why we measure it flat. Forget the apologetics for, well, that's because we've got a really big ball. Why can't we see any curve? Because it's so big. That just read between the lines much? No, don't need to. It's measured flat for everyone.
That's their first fallacy, is the special pleading. It's so big that it's flat. Oh, special pleading.
Can't have any flat surfaces on a sphere.
And to get the sphere, you need a flat surface, because you're going to be describing the angle measurements that you see through a protractor based on an equatorial value called radius. And that's radius of a measurement of an angle to Polaris. The whole thing back engineers beautifully and is at fixed values. I remember maybe 3 years ago, QE telling me there are values fixed in stone, 4 years ago, when he was describing the Black Swan argument, and how saying, oh, well, at best you've debunked the radius. No, the radius is fixed because it has to back calculate into the angle measurements to Polaris for latitude. That's how all the maps and grids work. The fact that they've taken us on a merry dance of conversion from flat plane measurements and angles to circles on a map, to circles on a sphere, to lines on a tube, to cutting down the tube down the middle and rolling it out as the Mercator projection. So there's enough steps for people to not appreciate that there's an initial measurement that's flat to make the globe, to make the tube, to make the flat map that we actually use with all its distortions. Most people just see the Mercator projection and go, well, I know that's not really the world. And if they look into it to even a slight extent, they'll be told it's a globe projection. And the reason it's distorted is because you can't have a flat map when the world's a globe. No, you can't have a globe unless you're measuring the world flat with angles to stars. But we never got told that till about 4 years ago.
Yeah, and it's never a globe projection. It's a celestial sphere projection from a flat plane. There's no globe projection. There's no globe. The emperor has no clothes.
Yeah, all there is the points projected through that protractor that you imagine if you've got a semicircle over your position as you measure the flat and parallel plane that is the sky and ground. Then you can imagine that the angles and lines from your position along the ground, slightly up above the ground, all the way through to zenith above your head, that swooping motion that you take to measure the angles that you see in the stars out at the horizon and above your head, you can say that that's a curved protractor-like semicircle arching over your head. Well, the line of the positions that would lie on that semicircle can be described as the celestial sphere. That's the sphere that represents the actual points that you would see through that protractor. Well, then you can put a smaller protractor inside that that's based on a radial value at 3959 miles, based on the minimum elevation angle to Polaris, with a Polaris-centric system, with another protractor wrapped around your position called the globe. So you've got you on a flat plane measuring angles to stars in reality. Then you've got a protractor wrapped around that with the lines matching up with positions that are respect to the ground from the center of Earth. So now you're in hell, even though you've already measured off a flat plane to get these angles. Then around that, you've got another semicircle representative of the points of light in the sky when positioned, having been measured as though they are on a parallel plane, because they are, so that you can represent them on another semicircle called the celestial sphere. So then you've got globe, flat plane, and celestial sphere all in one juicy dish. That's how your globe came to fruition. So the fundamental aspect of that, the starting point, Genesis, is the flat plane measurement. For all of the references beyond that, you start with latitude. That's flat plane measurements to Polaris. So the world's based on these flat Earth measurements. It's no wonder we're catching so much flack. It's the genesis of the globe, religion, and the reason we can't be censored out of existence. All they can do is promote Simon Dan above us. That's it. That's all they can do.
Did we get that video yet?
No, not yet.
Triangles yet?
Somebody can...
Sounds like it's going to be juicy.
Hopefully someone will dig out the Dave McKeegan video that's just come out. Stick it in Skype so we can cover it in a minute. Everyone recovered from yesterday's extravaganza? My show flowed into QE's show, which flowed into about 1 o'clock in the morning of me playing on games, making sure my new graphics driver doesn't cause any issues.
That's what I was going to say. The computer's ace now, huh?
Yeah, it certainly seems to be.
What a relief.
Yeah, that's down to the generosity of one very specific Patreon member who just approached me and said, "What do you need?" I asked my tech guy, he told me, gave me a price. I told the guy, he gave me the money, and my tech guy ordered all the parts and fitted them. From that moment on, the computer has worked perfectly.
Isn't that amazing? But nobody watches you anymore, Nathan. Your numbers are going down.
Yeah, what's all that about? People want to believe that the popularity of the show, i.e. how effective the redirection of people's searches on YouTube is. You're like, if you want to class the popularity of these searches, then go by people who are actually making anti-flat Earth content, because that's where all the searches get directed. And the fact that that's negative for our cause is neither here nor there. There's plenty of people searching, and the popularity's been sponged up by Dave McKeegan, Simon Dan, Professor Dave Explains. Those are the people who mop up the actual flat Earth searches. It's been redirected at the behest of the Congress in the States. That doesn't affect my stats. If I was to pay attention to how well Simon Dan's doing, I'd just go nuts with envy. Well, I don't. I pay attention to my own stats and how well I'm doing. And if there's any slight dips, then I'll address them by producing more material. Going live for members-only streams, although that wasn't actually a direct result of that yesterday. That was actually me testing a new graphics driver. But the point is that I can do things, especially if I've got a working computer, to mitigate if there are any unexpected dips in my growth. And all I'm looking for is growth. As a salesperson, that's what I was trained to do when looking at statistics. Are you growing is all you'd be asking. Well, I look at that daily and make sure that I'm pushing the needle in the right direction. When there is a little dip, you'll see me producing more material and moaning about the fact I'm up all night doing it. So when someone comes along and says, your channel's not growing, in fact it's dying, I go, no, it's not. I keep a very close eye on my stats. Now, in that instance, I think that particular dude heard me moaning about it because someone did it in the comments section. Has gone, I'll latch onto that. I'll gather up some stats where I can show that he's not growing. Labour those and have a little jab for as long as I can keep him annoyed for.
Right, he was affirming his bias. He had a conclusion. He looked for information that affirmed his bias. That's all that was. He wasn't looking at the information and drawing a conclusion. He had a conclusion, and he was looking at the information that backed his conclusion.
Yeah, and once he'd been left
What's
to
up
his,
with?
once he was left to his own
Sorry.
devices on one of the after shows, so he came in again after QE's show, and because it was QE running the show as opposed to me, QE just let him tucker himself out, and at the end of it, he's like, "Oh, you guys are all right, actually." And you're like, "Okay, is this how you interact with people socially? You join the group by having a little jab, trying to assert your dominance. Like, okay, if that's how you behave, nobody will want to be your friend." But at the end of it, it's like, "Oh yeah, you guys are all right." Yeah, we all think you're a wanker now, though. Anyway, right, fresh off the presses from Dave McKeegan. Please let him know at Nathan Oakley 1980 sent me. If you're a regular fan of the show, then you'll know the drill already. But what we do to invite these people to put links to our video and return the algorithmic love that we are, as we've just discussed, so sorely lacking. All of the searches for this subject go towards people like Dave and Simon Dan and all the rest of it. Right, I'm just going to do a quick sound check, but in the meantime, while I'm doing that, hopefully the people of my live audience, there's 81 people watching, can let Dave McKeegan know in the politest possible way at Nathan Oakley 1980 sent me. And yeah, like I say, if he were to make a response, hopefully he would put a link to my video in his. So that's now whizzing its way by for the live stream chat. Check it out. Like I say, I hope Dave does the same. Let's do a little sound check, make sure it sounds okay before we actually blast my audience's eardrums.
Hello everybody, hope you're doing
Very
well
quiet.
and thanks for joining us for another video. Now, flat earthers love to present observations which they claim debunk the globe, usually involving viewing objects way off beyond the horizon, and they argue those objects should not be visible as much as they are on.
No, you've already cracked up this argument. Viewing objects beyond the horizon. No, the objects are before the horizon in the black swan image that you just showed. The argument that goes along with it is specifically about the horizon and where the horizon is located, not the item, the horizon. If Earth was a sphere with a radius of 3959 miles, then every distance to horizon measurement can be no more than 1.2 times the square root of the observer's height in feet. That's Earth curve maths. That's your Earth curve maths claim. Distance to horizon in the black swan image that he just used is beyond the geometric limitations of a sphere Earth radius, 3959 miles. Therefore, the horizon's not Earth curve and the Earth is not a sphere. You no longer have a geometric Earth curve edge horizon as a result of that image. It's a demonstration with a logical consistency argument called modus tollens that attaches to it. Karl Popper is the example we give, because Karl Popper's example of a black swan is to say that you only need to demonstrate that one black swan exists to eradicate the notion that all swans are white, or in this instance, all horizons are Earth curve. The horizon is not Earth curve. It was debunked by that image. The argument is about the horizon, not the oil rigs, not the items.
On a globe based on their maths. No.
Hello? Based on their maths? No! What a numpty! Is this another Simon Dan moment where he tells me my reference frames are ruined? 1.2 times the square root of the observer's height in feet is your maths, Dave. Yours. It's Earth curve maths, you clown. Go ahead.
I think what he's doing is putting the we see too far on us for being on a sphere claim that we tell people not to make. You know, I think that's what he's attacking, not the black swan, but he's showing an image of the black swan as he attacks a different argument.
Exactly.
Normally because they've missed out some variables such as observer height and or refraction.
We've missed out observer height. What? If the Earth's a sphere radius 3959, then every distance to horizon can be no more than 1.2 times the square root of the observer's height in feet. Dave's just a disingenuous liar. He doesn't understand the argument, can't parrot it, and can't represent it to debunk it. He's just told his audience we haven't taken in observer height and that it's our maths. Your maths that includes observer height is debunked by these images. This image on screen now is a black swan. The distance to horizon measurement from your mathematics does not match this horizon. This is a black swan, showing that the horizon isn't at the geometric limitations you claim will block boats and buildings. That's your maths, your claim, your horizon, your observer height in feet that we declare in the modus tollens argument that he clearly doesn't understand. Can't even paraphrase it back to say what we aren't including when we use his maths to debunk his claim of Earth curve edge horizons. You just don't understand these arguments, Dave. You're just not very intelligent. You haven't comprehended the modus tollens argument, comparable with Karl Popper's Black Swan. You just don't understand it. Too much for you, son.
So I think they think refraction is just some magic excuse to explain away things.
Is that projecting? Because refraction is just an excuse. You won't be defining globe-Earth refraction in this bullshit. You don't know what refraction is. The chances of you being able to define it, if I was to now ask you, Dave, define refraction. And we'll see if that refraction definition has anything whatsoever with a horizon distance measurement based on observer height in globe Earth maths. Our maths. Your maths. Yeah? Will refraction in a globe context be explaining our positional geometry for horizons functions? No. But you don't comprehend the argument. This is just pathetic.
But one problem with a lot of the observations is they can be quite tricky for people to replicate for themselves.
They're observations! You're telling me how difficult it is to replicate a black swan is relevant to the argument that we haven't got a physical geometric sphere edge at 1.2 times the square root of the observer's height in feet as laid down in your maths?
If they're trying to figure out the shape of the Earth.
We're not trying to figure anything out. You've got maths that say where the horizon will be. We show how it's wrong. This isn't trying to figure anything out. You've already told us there's a horizon that's Earth curved that blocks boats and buildings. We've debunked it.
There's finding a suitable location.
Well, we're kind of into a false dichotomy.
Yeah, John. I think he's lost his internet connection or something. His mic's open, but there's no sound coming out. Try again, John. He said we're kind of getting into a false dichotomy. That was the last thing I heard from John.
Few objects going beyond the horizon, plus there's needing to know all the variables that are at play, and then there's knowing the maths involved in figuring out what you should expect to see.
Maths doesn't tell us what we expect to see our eyeballs do. Yeah? This idea that the globe Earth maths, what the very specific maths that we lay down in modus tollens, yeah, that maths. Yeah? The idea that that tells us what we should see would mean that we'd have a horizon at 1.2 times the square root of the observer's height in feet, and we don't. So immediately appealing to a maths to suggest that that dictates what we'll see. No, mathematics doesn't dictate what we'll see. And your globe Earth mathematics is a derivation of a flat Earth measurement, Dave. Maybe this would be the main point I would suggest you respond to. The globe Earth mathematics that you suggest is ours when we lay out an argument that you haven't understood is a derivation of eye level and surface level. That is to say that the 1.2 times the square root of the observer's height in feet, the one you said we ignored in your maths, even though it's the basis of the bloody argument, you stupid boy. Those maths are based on a derivation from eye level to surface level to infer that there's a geometric horizon below surface level at 1.2 times the square root of the observer's height in feet in your globe maths. Ugh, he just doesn't understand these arguments. Why am I even responding to him? The guy is stupid.
So today I want to present a much easier observation that pretty much anybody can make around sunrise.
So I'll hand wave and completely misunderstand how the Black Swan argument works and what the photo's representing and whose maths and whose claim it actually is in favour of a completely different argument. I mean, it's almost like you've given a complete hand wave to this argument you didn't understand, Dave. Oh, my bad, that's exactly what you've done. But moving on to something else that isn't this argument that you haven't overcome by telling us it's our maths without height of observer. I mean, that was a pretty critical detail that if you actually had ever even heard the argument that's labelled the Black Swan modus tollens, you'd know that observer height in feet is in there, mate. But you seem to assert that it wasn't.
Sunrise or sunset that is easy to explain with the Earth being a globe, yet seemingly unfathomable if the Earth is flat.
All claims that come from a globe will start with flat Earth measurements. So this idea that something that works on a globe, well, it'll have its origins and genesis in a flat Earth measurement for a start, doesn't work on a flat Earth is absolutely absurd. And I'm sure we'll show how.
How the bottoms of aeroplanes can be...
So is this useful? Where are we utilising the bottoms of aeroplanes in a day-to-day practical example that will actually be used for something? Is there an example where aeroplane bottoms are useful for things? Now, when looking to the sky, we can use stars and the sun for navigational purposes and not dying at sea. I would challenge Dave to give any useful practical application for the example that he's about to give. There won't be one. It'll be some garbage he's come up with to try and explain how a perspective representation through a protractor that I described as the globe earlier is going to somehow be representative of the angle to the bottom of this plane.
Be lit by the sun. And for anyone who struggles with maths, this doesn't really require any. Although if you do struggle with maths, then you should check out today's sponsor, Brilliant.org. By name, by nature, questions on Brilliant for the top of the Rockefeller Center for sunset. We got there about an hour before the official sunset time and stayed there taking photos of New York until long after the sun had disappeared from view.
What, like at 1.2 times the square root of the observer's height in feet because it's gone behind a physical geometric sphere edge? It seems like the original argument that debunked the notion that we've got a physical sphere edge for the sun to go behind has been completely hand-waved. And now we're using an example where the sun's going behind a physical geometric sphere edge at 1.2 times the square root of the observer's height in feet, Dave. Talk about whistling past the graveyard. How sad.
Yeah, Nathan, he thinks that the horizon is Earth curve. Oh dear.
Yeah, he doesn't understand. He's one of those numpties that's taken years to even comprehend the argument. When you lay down a notion that it doesn't include observer height in their maths that he says is ours. Ugh, it's just sad. The failings in comprehension are beyond our comprehension. Go ahead, whoever that is.
I was just going to say we're back to the horizon having an address. We're back to that again.
Yep.
Yeah,
Good morning,
having
guys.
completely hand-waved the Black Swan where we debunked the horizon as Earth curve. Moving on, if the sun goes behind Earth curve...
Now, on a globe, the sun disappears below our horizon because...
The horizon at 1.2 times the square root of the observer's height in feet. Let me introduce you to a little argument you just hand-waved called the Black Swan. If the Earth was a sphere with a radius of 3959 as depicted in this example, then every distance to horizon to block the sun could be no more than 1.2 times the square root of the observer's height in feet as laid down in your begging the question proof of nothing perspective hijacking Earth curve maths that you use to claim the Earth is blocking the sun with a sphere edge horizon. Distance to horizon in the Black Swan, beyond the limitations of a sphere edge that blocks the sun. You're getting it down, son. Have you got a pen?
because the Earth is rotating. Flat earthers argue that the sun is actually remaining at a constant altitude above a flat, stationary Earth.
No, we do not. On a daily basis, we ask numpties like you that claim it's 93 million miles away for your measurements of your distance to your claimed sun. That's what we ask you to do. We do not claim that you can measure a height of the sun. Let me explain why you can't measure a height of the sun. Because you'd require an inference of physicality when taking elevation angle measurements to it. Now, when taking elevation angle measurements to the sun at your zenith, that would be to say that it is directly above your head. And as it recedes towards the horizon, the inference of an angle measurement would suggest that when it reaches the horizon, it's crashing into the ground. With its physical nature, that voids any assertion that you can acquire angle measurements to get height. which is how all of the numpty, anti-flat Earth rhetoric that you say we claim has to function. We don't claim this. This is a stereotyping fallacy. We ask for your evidence of your distance you do claim to your sun at 93 million miles. And we tell you that the R value insertion of Huygens' assumption that Venus has the same spherical radial value as Earth came from a spherical radial value measurement off a flat plane for Earth as a sphere to transpose onto Venus for Kepler's third law of interplanetary motion to have scale that Huygens applied to give you 93 million miles to your sun. Meanwhile, me as a flat earther, I don't claim a distance. But you'll hold it up as a straw man, won't you? Like a scumbag.
Although they can't agree on what altitude the sun is.
What, when we ask you for your ascribed 93 million mile distance that you ascribe to your sun when we say we can't measure it? No, it's not that we can't agree. You can't measure something that doesn't have an elevation angle adjustment with altitude. If the angle's not changing as you're going up higher, how can you possibly infer that you're getting closer to it? The angle doesn't change. So you're not getting a height to these things.
Many flat earthers have said it's around 3,000 miles. Others have said it's much higher than that, but most of those aren't prepared to actually put a figure on it. But the general consensus amongst seemingly a vast majority of flat earthers...
Sorry, why are you defining the general consensus of flat earthers? I don't get it. So what, your stereotyping fallacy is what you're debunking? No, we have got a globe rhetoric. You seem to ascribe it to us in the maths of the black swan argument. So you won't even accept your own bloody maths. You'll hand-wave an argument that includes it and shows it not to work, to immediately move forward and use a horizon that's Earth curve at 1.2 times the square root of the observer's height in feet, that you said we hadn't accounted for in your maths, in the argument where we take apart your Earth curve. But yet now we've got us being ascribed models and heights that we can't agree with. But general consensus that Dave says is, it's what?
Is that it is much higher than aeroplanes fly.
Oh, really? How very vague. That's the general consensus, is it?
And what we perceive to be sunset is actually just the sun moving away from us.
It is factually moving away from you if you want to describe its GP position above the ground as it recedes towards the horizon. That's a fact. I can demonstrably show how it moves over a different piece of land that's far away. Those are facts. In fact, our entire mapping and time system's based on it.
Except whilst I was at the top of the Rockefeller, soon after the sun had set, so the sun itself was no longer visible, but the sky was still quite bright.
Has it gone beyond a physical geometric sphere edge horizon? Because my understanding of how angles to positions in the distance work is that the more limited your angle, the less you can see. And as you raise in altitude, you'll open up the angle to a position that's further away. That is to say, the higher you go, the further you can see. Now, given that we can demonstrably demonstrate how the sun moves over a different geographical position as it recedes to the horizon in a sunset, I can say, without question, it's moving away. Because I can demonstrate it with its ground position, where it's above, and how that's further away with time. Oh, time? What, the very basis of this system forming parts of our maps that are flat? I don't know if Dave's getting a pen to actually debunk any of the things that I'm putting down, because he's about to go up in elevation and say, wow, I see the sun again.
I spotted about a half a dozen aeroplanes cruising in the sky between myself and where the sun had just set, and they were glistening with sunlight bouncing off them.
And?
Now, in this photo that I took, this antenna in view is the top of the H&M building. So I had a look at Flight Radar 24, and at the time that the photo was taken, there were several planes in that direction cruising just north of Baltimore, which would put them in the region of about 225 kilometers or 140 miles away. Some obviously a bit further, some a bit closer, but they were in the general vicinity of southern Pennsylvania.
Those are flat Earth distances that you've just given. The only way you can calculate those distances is over a flat surface. He's just given you a flat Earth proof for the distance between him and his estimation to the planes that he's going to hopefully give an elevation angle to, or a height of. Because when he gives us the height of these aeroplanes, the height's going to be with respect to sea level, requiring a flat Earth.
And the key question is, how is the light reflecting off a plane between myself and the sun that would allow me to see a reflection of the sun?
Who cares? I mean, the fact that we have got Chris Berry demonstration of how you can move a light away from something that still remains higher and lights the bottom of it. This is crap. Doesn't prove anything. It certainly doesn't prove you've got a physical geometric sphere edge for a horizon when you inferred it. When you told us that you'd got a horizon for the sun to go behind, you're making a claim that was debunked in the hand-wave dismissal of the Black Swan that you did not address in the first part of this video. Hello, Quantum Eraser.
High school physics covers the
video.
Don't what?
You're going over the wrong video. You've already.
Yeah, I know it.
Oh, well, whoever sent me the wrong video, I blame you. Is this the right one? Equatorial mounts. Yeah, I thought we were covering this one. I thought we were just going to get to the equatorial mounts later.
But
Obviously
that's
not.
over a year ago.
Oh, well, that's rubbish. Well, we're going to get a twofer. Okay, let's share this video instead. Right, please let Dave McKeegan know on this video. At Nathan Oakley 1980 sent me the whole idea being that he returns the love that we are sending his direction. 88 people, almost 90 people watching. So if you are amongst the live audience, go and let him know. This video link for this video that we should have been covering in the first place is now scrolling its way by in the live stream chat. Over 90 people watching, so yeah, please let him know. At Nathan Oakley 1980 sent me.
Hello everyone, hope you're all doing well and thank you for joining us today. In a recent video I did in response to Flat Earth and Nathan Oakley, I briefly showed this equatorial camera mount and mentioned about them being used for photographing the night sky.
I didn't see that. Equatorial, you say? What, like a flat plane? So this is a mount that works with a flat plane. Okay. Well, that's a flat Earth proof. Within 17 seconds of the video, you've proven that your mount works on an equatorial plane.
Subsequently, there were a few people expressing interest in learning more about them. So in this video, we're going to look at why you would use them, how they're able to function, and crucially, why, if the Earth was actually flat, they wouldn't be able to work.
Right, you're going to explain how a mount that works on an equatorial plane wouldn't work on a plane. This seems insane. Anybody else tracking where I'm not?
Now, when it comes to view,
like this is the same guy that sat around and told us all about how you need a flat baseline for a whole video or two, and now he pulls out his equator, but this somehow still proves a ball. I'm confused.
Yeah, maybe you could tell us where he gets his equator from.
viewing the night sky, even if we go into the middle of nowhere, well away from all forms of light pollution, our eyes just physically can't see anywhere near the number of stars that you see in photographs. That's because our eyes are seeing things in real time, and some of the stars are incredibly dim. As in, we don't get much light from them. I'm not suggesting that the stars are stupid. I wouldn't know, I've never met them. So if there aren't enough photons from a particular star entering our eye, then our brain can't distinguish that the star is there at all. Cameras kind of work on the same basic principle in that they have a sensor with millions of photosites.
Oh my god.
Like the receptors in our eye. Now, when photons enter a photosite, it generates a small charge. More photons equals a higher charge. At the end of a photograph, the camera will measure the amount of charge in each photosite and assign a value to it to turn it into a digital signal.
Are we going to get to the equatorial plane or what?
For example, if it detects no measurable charge, it will assign it a 0, which tells any computer that that pixel is to be jet black. And if it reaches the maximum charge that that photosite can handle, then it assigns a number like 255, and that tells a computer that that pixel is pure white.
Oh, very interesting.
So for stars to be clear in an image, you want a high enough charge being generated by that particular...
Meanwhile, Earth is measured flat. he's going to level his tool with respect to an equatorial plane. That plane is the angle measuring plane that we use to derive a sphere Earth by inference. The minimum elevation angle measurement to Polaris giving you your radial value and equatorial value for the outside edge of a sphere. Minimum angle you can view Polaris from. So, I don't know why he's babbling on about cameras. Earth's being proven flat with this mount he isn't jabbering about yet.
Particular photosite, that it creates a clear bright spot in the image rather than something that's just barely above dark grey and looks like a smudge. Thankfully though, unlike the human eye, cameras are not limited to seeing things in real time. They can gather up lots of light for a single image just by leaving the sensor exposed for longer. However, we then hit the hurdle that the stars aren't staying fixed. They instead appear to move across the sky. So if our camera is in a fixed position relative to the ground, like say on a static tripod, then each star will slowly drift from one photosite to the next, and so the total amount of light for that exposure will be spread between different pixels rather than all focused into one. This is what causes motion blur in images, and when
Oh my god, this is so tedious. How does your flat plane only measurement with an equatorial mount not work on a flat plane when it's a flat plane that you're measuring and leveling to? When are we going to get to that?
when stars blur, we often refer to it as star trails. Now, the amount of blur that we would see will depend on our viewing angle. A wide
Viewing what now? Viewing angle? That sounds problematic for a sphere. I'm pretty certain we're going to need a flat Earth for this angle. Let's hear more.
wider viewing angle means that each photosite covers a larger part of the sky, so a star would have to travel further across the sky before it moved into the next pixel. Whereas a longer focal length magnifies everything, including how quickly stars appear to move across the frame, and so they would cross over pixels much sooner. As a rough guide, photographers will often divide.
Is he just trying to bore the crap out of his audience so that they think he's actually got a point to make about proving how an equatorial mount, that's a mount that works on an equatorial plane when leveled, wouldn't work on a flat plane when leveled? If he rants about cameras long enough, he'll lose half the audience. He'll still make his numbers up. They'll all tune out within the first 3 minutes.
Divide the number 500 by their effective focal length to tell them approximately how many seconds they can expose for with a camera before they start to get noticeable star trails. For example, a 20mm focal length would allow about 25
Oh my god, this is painful.
seconds of exposure time, whilst the 200mm focal length would allow only 2.5 seconds. But if you want to photograph deep space objects such as galaxies or nebulas and the likes, then you ideally want a very long focal length in order to see as much detail as possible. But such long focal lengths would then create very short exposure times. This is where motorized mounts can solve the problem.
Okay, finally.
And speaking of solving problems, like the problem of trying to come up with a good segue to the sponsor of this video,
What, right before the bit that's going to annihilate you for 103 people of my audience, you're going to go to your sponsored segue, put a little bit more distance between this garbage that requires a flat plane?
online. I also used its breach scanner tool, which allows you to VPN to route your data through that particular country, value for staying safe online. And if you agree, then why not head over to Atlas VPN via the link in the description. Now, the purpose of a motorized mount is to move your camera or telescope such that it remains fixed in reference to the stars rather than to the ground. Now, if you set this up correctly, it means you could leave your camera pointing at a particular star.
How do we set it up? I wonder how setting it up correctly would affect that. Is he going to detail it? We're now, what, 5 minutes into the video? Halfway through.
For hours at a time, and the star would remain perfectly fixed on your camera sensor. Now, there are different types of trackers. You can get guided ones, such as this telescope mount, which has motors that control both its rotation and the telescope's elevation. And you set this up by selecting 2 or 3 stars as a reference in the handset, and then you point the scope at each of those reference points, and from that, the handset can work out exactly where you are in the world and where everything else is in the sky.
How does that relate to the surface? Because the machine's got to be leveled. And the axis to measure elevation is the angle with respect to the leveled tool on a level surface. That's how you get the elevation. That's what it's detailing when it references the stars in their position. Yeah, it's their elevation angle. That's a flat Earth measurement that you're referencing. Were you unaware that that elevation was an angle with respect to the level of the tool that you've used? Because it is.
I could then say on this that I want to view the Andromeda Galaxy, and it would drive the telescope round to it and keep it tracked.
How would it know? Would it be because we've tracked the positions with respect to the ground? Yeah, it would. These positions are logged in the almanac. We know where the stars are going to be because for quite a considerable period of time we've been tracking their motion. And their motion is tracked with respect to their angle. So their elevation, as you described it, is an angle description with respect to a horizontal plane of reference. The same horizontal plane of reference that you leveled your tool to. Notice he hasn't mentioned that yet. Not once. 6 minutes into the video. Over halfway.
That's how he's going to get away with it. He's never going to reference the ground.
Yeah, all he's done is reference the sky, but he referenced the sky with the elevation of the star. So I can still use his words to describe how those positional pieces of information for the star are with respect to their elevation, and that's an angle off a plane. 100 people watching my show. Please let Dave know that his reference, if he doesn't actually even address the equatorial plane, that this is described when actually measuring something called the celestial sphere, which is with respect to a equatorial plane, because that's how this tool works. Everything he's detailing is flat, but he's just not mentioning it. He hasn't mentioned leveling the tool.
You know, people could argue that that's possible on a flat Earth since the telescope knows where everything is.
All right, no, the fact that you're leveling it to the equatorial plane and then measuring the angles, that's elevations, of the stars with respect to that plane that you leveled the tool to. So it's a prerequisite, Dave. That's why I was confused at the beginning. You seem to think that without highlighting the prerequisite leveling of the tool with respect to the equatorial plane, so you can measure these positions to get reference of the stars and where they are in elevation, yeah, that's a flat Earth prerequisite, Dave. But now you're going to ponder how that might not work on a flat Earth? That's a prerequisite.
This equatorial mount, however, isn't as fancy. With this, you have to face it either directly north or south, depending on which hemisphere you're in.
Sorry, north or south are directions on a flat Earth, my friend. When you say which hemisphere you're in, are you talking about the hemispherical positions of the stars that you reference? Because that's all you've referenced so far. Well, that's a hemispherical celestial sphere that's denoted off a flat plane. So when you say hemisphere, the only hemisphere that's going to be with respect to this tool is the celestial sphere, not globe Earth. That doesn't factor into you levelling your tool to the equatorial plane. Not again that you haven't mentioned it yet. I wonder why.
You then wind this elevation dial to match whatever your latitude is.
Latitude? What's latitude? Oh, would that be the elevation angle measurement to Polaris off a flat plane? Yeah, it would, wouldn't it? So this tool and these markings only work on a flat Earth, Dave, because they're measuring elevation angle measurements to Polaris. That's what latitude is, Dave. Latitude is a flat Earth proof. It's the flat Earth proof that means we don't get eradicated. Obviously, you're going to get all the traffic when people search for your boring crap, interjected with sponsorships, before you even get to, oh, by omission, ignore the fact that you've leveled your tool. But you do leave enough detail for the actual people who know how the world works to point out that his Polaris measurement for latitude is a flat Earth proof also. There's quite a few flat Earth proofs in here, Dave, including latitude. How'd you measure latitude? Oh, it's an elevation angle measurement of a flat plane to Polaris? Yeah, you'll need a flat plane for that, like this tool does.
So if you're at, say, the North Pole, you're at 90 degrees north elevation, you wind this dial.
Sorry, how can you be at 90 degrees on a sphere? There is no 90 degrees to a spherical surface, Dave. Do you not understand how spherical surfaces work?
Until you get to 90 degrees, and the mount is pointing straight up towards Polaris.
Straight up towards Polaris is a flat Earth prerequisite. Up. What, with respect to horizontal? Like vertical? Yeah, you're describing flat Earth prerequisites, my friend. Meanwhile, you have to level this tool, and what you've just plonked it on has no level surface whatsoever.
If you're at around a 45 degrees latitude on Earth,
What, 45 degrees? That would be... The Polaris is 45 degrees in the sky with respect to a horizontal plane of reference. Yeah, the measurement of that 45 degrees that you've just described to then point at the globe would be a measurement from inside the globe in hell if you're going to infer the globe's used at all. But the actual measurement is off a flat plane, Dave.
and that puts you somewhere around, say, Bordeaux, for example. You wind 45 degrees onto this mount, and you can see, relative to the globe, the mount...
No, the mount isn't moved round at 45 degrees. The mount's still levelled with the ground. You levelled the tool. You see, what Dave's now showing you, because he's a scumbag, liar, and deceitful, is the tool no longer being level. No, Dave. You level the tool and it remains level, but you're now showing an audience that the tool is now at 45 degrees. No, your tool doesn't go to 45 degrees. But when I described to lumpy gas in a vacuum in the pre-show and at the start of this live show, how they describe you being on the protractor, you can understand how this level tool at 45 degrees in the centre of the sphere would be a level tool on the equatorial plane. But he's describing the tool now being at 45 degrees. Now, your angle measurement to Polaris is 45 degrees off a flat Earth. The tool's not at 45 degrees, Dave. You level the tool, Dave. Does it still look level, Dave? Is this what you think happens to your tool, Dave? No, it always remains level, Dave. It's a very key detail to using an equatorial mount. It's a detail that you didn't tell your audience about, though, isn't it, Dave? I wonder why you left that part out. Was it so that you could show them that the tool is at 45 degrees when you pretend that the protractor of the globe Earth with the equatorial plane with you in the centre of it, levelling your tool to the equatorial plane, that means the tool is at 45 degrees? No, the tool's level, Dave. Always level. It's got a bubble in it, hasn't it, Dave? So why would you be telling your audience that your tool's at 45 degrees? It isn't. The angle measurement and the references that you use are all angles off a flat plane. But you think you can just stick the tool at 45 degrees and blag that it's on the protractor you're measuring? No, Dave. No.
It's still pointing straight up towards Polaris.
Sorry, straight up to Polaris? No, it's just pointing at 45 degrees, Dave. It was level when you had it at the North Pole. Then you stuck it at 45 degrees. So you're talking in double speak, my friend. Contradiction in terms. Dave needs his tool, says Roger Ledwell. Thank you for the super chat.
Likewise, at the equator, it's at 0 degrees, and again means the mount is pointing up towards Polaris.
So you think that when you level your tool is standing sideways, Dave? Because you're literally telling the audience that your tool's lying on its side. No, Dave, at no point does this tool do that. No, Dave. Your tool's always level. You level the tool when you set it up. The tripod hits the ground. It doesn't hit the wall next to you. But that's what he's telling his audience. Because in order to do this, you have to take the tool that's level and the angles to Polaris, that's 45 degrees, and infer that you are on the protractor that is being made with the angle measurements of this tool. Therefore, the tool's at 45 degrees. No, it isn't. Tool's level. Always.
Perfectly on the equator, you also have the option of being able to point south as well, not just north. Obviously, if you're south of the equator, you then have to point this directly south.
No, Dave, you level the tool. That's what you do. You level the tool.
Now, in the northern hemisphere, Polaris...
Why hasn't he mentioned this? We are literally at 7 minutes and 26 of this 11-minute video. And he hasn't once told the audience that this tool requires levelling. He hasn't said it once. We know that Dave does his tool at home. Okay, thank you, Roger, for the other super chat. Really appreciate the support.
He knows. He knows.
Polaris isn't exactly where the axis of rotation is. It circles...
Axis of rotation? What? An axis with respect to a horizontal plane of reference? To describe Earth with a Polaris-centric axis, you need a Polaris-centric zenith. That's to say, Polaris on a flat plane. That's what axes is. It requires a flat Earth. Go ahead.
Is this guy retarded?
He's lying by omission currently.
Yeah,
No,
he's a deceiver.
He's trying. This is tantamount to trying to disprove the existence of airplanes by giving a tour of the Boeing manufacturing plant.
Yeah, it's trying to disprove.
This guy, you're retarded, Dave. You're a retard. Thanks.
Yeah, this is all guff.
Just around it. And our perspective of this will shift depending on where you're viewing it from.
Hold on. Your perspective. In the previous video, you were describing Earth curve mathematics with geometric horizons that didn't have perspective in them. I specifically noted the perspective hijacking Earth curve maths that you denied when you suggested that we ignored height. That's perspective hijacking Earth curve maths that you asserted for the horizon when it blocked the sun, ignoring the Black Swan argument. Okay, now you're asking us to infer perspective. No. The way that the light will travel from the parallel plane of the sky to the ground, so you can get an angle with a level tool, that's the equatorial mount that you haven't mentioned to your audience, needs leveling. Yeah? That's a description of an Earth that's going to be formed spherical based on the angle measurements to that parallel plane.
So you use an app like Polaris View, which takes your phone's GPS data and time information and will work out where Polaris is relative to the axis of rotation for your...
Right, where Polaris is when you're taking GPS data. GPS data is flat. That's flat Earth. It's in reference to the transverse Mercator projection. So the positions are on a grid that makes no sense because there's lines that are running parallel that point north. That grid has come from a tube, and that tube has come from points projected out from a globe onto that tube prior to be cutting open and rolled flat. And that globe has come from elevation angle measurements to Polaris, off a flat plane. So the whole progression of this description to get to GPS, to reference Polaris in the first instance, is going to require 3 or 4 steps that use a flat plane to measure Polaris to get the grid. For you to say that you can use the grid, that's GPS and transverse Mercator, to suggest where Polaris is in an app. You need a flat Earth for all of this, Dave. This is about as flat Earth proving and fruitful as you can possibly be.
Your vantage point, and you fine-tune the mount by using the spotoscope on the back to align Polaris up accordingly to where it should be relative to the axis of rotation.
Right, now you're going to describe Earth with an axis that's described by having a radial value derived from an angle to Polaris and the description of that axis with respect to a horizontal plane of reference. But you're going to now stick a spike through a globe Earth picture? It's just sad. Shout out to Roger Ledwell. We need a quick... What's this? We need a height, quick, sharp. Okay.
Once you've aligned it, this mount is then perfectly parallel to the axis of rotation for the sky. At that point, you turn the motor on and...
Right, again, look at this diagram. No, Dave, your mount isn't sitting sideways. And this would be glaringly obvious if you'd have disclaimed the fact that you level the tool. It's the first step when using an equatorial mount. Level the tool. You've got it depicted sideways. Now, if you can show me you sticking your mount to the wall next to you, like this, then it might have some credence. But what you're actually doing, Dave, is taking the mount that has to be level and describing the angles as though they run parallel with the axis. All this is doing is apologising for why, when they actually utilise the equatorial plane with a globe, the equatorial plane will be at the centre of this sphere. That is to say, the mount will be level in the middle of the globe, so that it matches with these parallel rays that he's inferring when he says that the tool is at the angle of Polaris in this instance. No, the angle of Polaris is just the angle of Polaris, measured on a plane. doesn't mean that the tool itself is at the angle that you've just measured with the tool, and that therefore the tool's hanging off the side of a sphere Earth. That's absurd. The sphere Earth is merely the protractor that you would measure the angles through when levelling the tool to the equatorial plane. In hell for you.
And it will begin turning the mount plate up here, which is where the
Sorry, this looks like it's not sat sideways on a wall, Dave.
camera's connected to. And provided you've selected the star setting on the side, it will spin this plate at 15 degrees per hour, which
15 degrees per hour, as in a measurement of the star's movement in degrees with respect to a horizontal plane. These are all flat Earth proofs, Dave.
perfectly cancels out the Earth's rotation and will...
Wait, Earth's rotation? No, Dave, we weren't transposing the tool that measured the 45-degree angle to Polaris as though the tool was at 45 degrees. The tool was leveled and it just measured an angle off a flat Earth. That doesn't mean we're on the outside edge on a rotational point, because that doesn't work anymore for any of the angles that you've used for every example so far. In spite of you not mentioning the fact that the tool had to be leveled to get these angles, because it did.
will leave your camera perfectly fixed relative to the stars with no drift. You do sometimes need a few attempts to get the alignment exactly right, and if you're in the southern hemisphere, you might need a wing and a prayer as well. It can be done, but it just takes a little bit more work because there's not as clear a pole star to reference as Polaris. You
Not as clear a pole star. There isn't a pole star in the south.
end up somewhere near BQ Octantis. And you also need to select on the side whether you're aligning to the north or south polar axis, because this will change what direction the camera's rotating. Now, if the Earth were flat, well...
Sorry, so now going to juxtapose all of these flat Earth requirements and flat Earth angle measurements for elevation and flat Earth descriptions of equatorial planes and flat Earth angle measurements to Polaris and flat Earth prerequisites for latitude. He's now going to say, if that works on a flat Earth. Yeah, I would just ask Dave's audience, that would be my audience I'm sending to him by letting him know at Nathan Oakley 1980 sent me, to ask him why, at the 9-minute mark of his video, he still hasn't mentioned that this tool must be levelled. Why hasn't he mentioned that?
Well, the direction change shouldn't be necessary because
sure
on a flat surface...
Sorry. I was just going to say, I'm sure that part of the reasoning for that is that there are many people that in their mind, they know what the definition of level is, right? So it's the anti-flat Earth guys that will tell you level is somehow curved because that's batshit insane. But I think there's an audience that he's aware of that will hear this and say, well, obviously level is not curved. Level, like the very definition of it, is the opposite of being curved. So why would he just lay that out? You know what I mean? Like, I don't know if this guy is a straight anti-flat earther or whatever. I don't know what his angle is.
No,
really.
he's retarded.
Yeah, I mean, besides that, I know that's his angle, but you know what I mean? Like, that's how I feel. Like maybe that's why he's not actually coming out with that, because there might be people that will say, well, level, what are you talking about? Because, you know, in the regular world, level means a certain thing until you get to this conversation. And then
So
all of a sudden, that definition. Yeah.
So does flat. So hit him with the wall, chocolate.
Yep. Hit him with it. Hitting himself with it, actually. So.
surface, the stars should all be moving in the same direction across the sky. More crucially, this method of alignment is completely wrong for a flat Earth. We're not trying to align to a specific star.
Is it just me, or has he now got the tool slanted back on a flat Earth pizza pie azimuthal equidistant projection? Well, Dave, is this the reason why you don't tell people that you level the tool? Because you do, but you don't seem to be doing that. You seem to be strawmanning us like we'd lean our tool backwards because you think that the tool's angle that it's measured is actually the position of the tool. No, Dave. No. You see, I'll say it once more because Dave is obviously disingenuous. That would be to say lying by omission so he can make this garbage example. Dave, the tool gets leveled Yeah? Was that why he didn't mention it, so that this straw man would work at the end? Wow, Dave, is this the standard? Give him 100,000 views.
We need to align ourselves parallel to the axis of rotation in order to be able to counteract it. For example, if you were standing on a merry-go-round and you wanted to keep a point around you of the world in your frame, then you would turn yourself in the opposite direction to the merry-go-round, but whilst you're standing on it, parallel to the merry-go-round's axis of rotation. So we're not aligning directly to a pole star. We're using the star and our time and location information to work out where the axis of rotation is pointing to relative.
No, those time-based informations, that's the sun, in terms of longitude. Those positional informations for latitude are angle measurements of a flat plane to Polaris. These concepts that you use to infer that you've got an axis being with respect to a horizontal plane also, don't mean that you have a rotating Earth. Because all of your inferences come from measuring angles with respect to the ground, not with respect to a rotating surface. That hasn't happened. Besides, you and your reference frames have been ruined.
Exactly.
End quote, Simon Dunn.
Yeah,
towards
I
at
was
any given
asking,
time.
wait a second, did he prove the Earth was rotating yet?
No,
He's
just
right
assumed
into
it.
it. Did he forget about that?
No, he just assumed it. He assumed that the axis of rotation described by measuring angles to Polaris with a flat plane means that the ground he's standing on is rotating through an axis. No, your inference came from flat Earth measurements. It's absurd.
Time.
That's a begging question fallacy.
Yeah, he's just
Dave?
assumed it. Correct. It's begging the question. It's just assumed by pure fiat that Earth is rotating, because if Earth's rotating, here's an example of a rotating roundabout.
Well, the axis of rotation for stars on a flat Earth should always be perpendicular to the ground. So these mounts should always just be facing straight up, rather than...
Or what, like they are? They're all leveled. This is how you would put... So your argument is to say that what we'd have on the equatorial plane is lots of level mounts. Yeah, we would. That's how it is done. It doesn't matter where you are, you always level your tool. So this is an accurate depiction if you want to infer that there's an azimuthal equidistant projection by strawman fiat that we don't claim. But you'd still level all of these tools exactly how it's depicted here. That's how they work. Maybe if you just don't mention that, when they're all level, and you haven't mentioned that you have to level the tool, people will think that, well, this is obviously wrong.
and faffing with trying to angle it in a specific direction.
What, like towards Polaris? Like explicitly detailed by you as how you use the tool? Oh my god! So everything you've detailed about using the tool, negating the fact that you tell the audience that you have to level it, right, wouldn't work because you'd be leveling the tool? This is so pathetic.
A flat Earth would essentially just be aligning as though you're always at the North Pole. Yet,
Would it? Is that how an equatorial mount works? Because that's not how you just described it. Minus the leveling the tool bit. But now, obviously, all these tools are level. Yeah? I mean, what is the equator? The equator is the minimum elevation angle measurement to Polaris as you detailed when you told your audience about latitude. But now you're inferring that, what, latitude doesn't work when it's flat? That somehow we're going to not be pointing at the minimum elevation angle to Polaris when we describe this point you've labelled as equator? That's what the equator is. Yeah? North Pole, that would be the zenith position for Polaris. So all of these are, when you say, well, it'd be pointing straight up. What, when measuring an angle that's at its minimum for Polaris at the designated equatorial location that you've marked it as by label? No, Dave, these are crap straw man arguments. They're really garbage.
yet on the equator, this thing has to be angled
Hey, Dave, why haven't you mentioned that you level this tool? Just asking for a friend.
horizontally, either north or south, to align with the axis of rotation.
So, no, that's what equator is. When you point it, essentially, effectively, in orthographic view, towards the horizon, as you've just described by moving these arrows, that's what the equatorial minimum is. The minimum elevation angle measurement to Polaris on a flat plane. That would be to say that your tool would be pointing horizontally. Yeah? That's what it is.
Well, we're into we're
Okay,
into
Tom.
the false dichotomy now. All of his positive claims required the Earth to be flat. Now he's describing how the Earth wouldn't work, or how this tool wouldn't work if the Earth was flat. It's false dichotomy.
Yep.
A false dichotomy that uses a flat Earth to make his globe claim and then says that the flat Earth doesn't work with it if you don't mention that you're leveling the tool.
Which is only happening if the equator is perpendicular to the North
So it's only happening if you are standing sideways. No, you see, the equator isn't you with your tool pointing sideways. The tool doesn't get 90 degrees or 180 degrees, depending on how you want to look at it. The tool is still level. This is garbage, Dave. The tools aren't level in this diagram, which is why they don't work on a globe. They work on a flat plane. Equator is the angle at its minimum on a flat plane when measuring Polaris. North Pole is you at the zenith position of Polaris, at its GP position, my bad. Polaris at your zenith. That's what these concepts are. But for all three concepts, the tool must be level, Dave. These tools aren't level, Dave. But you say that this is how the world is? No. What you're doing is you're measuring a minimum elevation angle to Polaris and then pretending that the tool sits sideways when the tool is always level. How sad. You guys need a flat plane more than we do. Yeah? Because without it, you wouldn't have the tool level, like in this diagram here. The boy thinks there are no elevations on FE. Yeah, I don't know what he thinks. He's just nuts and ignorant.
This
Pole.
is the point
Otherwise,
I was making last night.
Go ahead.
Nice diagram, this, Nathan. You see, when you do this on a ball, and you've got somebody with the pole star at the zenith at the North Pole, and you're at the equator, and you're looking at the North Star, the pole star from the equator. Can you see that you're not looking at the same point as the zenith? That those are now parallel lines.
This boy's a retard. Fur.
it would be like trying to counter the rotation of a merry-go-round by lying down and rolling around on it. It's
Well, there's a non sequitur false comparison, if I've ever heard one.
worth bearing in mind as
What
well,
did he
this
say?
isn't a smart
That it'd be like if you're rolling around on a merry-go-round. You're like, no, that's completely non sequitur. False comparison, non sequitur.
tracker. It doesn't know where it's positioned or what it's looking at. It works without any form of internet connection or GPS location. It's just a single plane motorized mount that will turn the same regardless of where you point it. It just so happens.
What did he just say?
A single plane?
Just listen to that again.
That's what I thought I heard, but I was like, nah, he didn't say
to
that.
the North Pole. Otherwise, it would be like trying to counter the rotation of a merry-go-round by lying down and rolling around on it. It's worth bearing in mind as well, this isn't a smart tracker. It doesn't know where it's positioned or what it's looking at. It works without any form of internet connection or GPS location. It's just a single plane motorized mount that will turn the same regardless of where you point it.
Yeah, a single plane motorized mount that requires leveling to the equatorial plane. And he is literally lying by omission, because it is going to get to the end of the video, and at no point whatsoever will he detail the very specific requirement of leveling the equatorial mount. He's just not going to even mention it.
It just so happens that it only creates the result you want when you've aligned it perfectly with one of the two axes of rotations in the sky.
No, you level it, Dave. That's what you do. You seem to be lying by omission. Yeah?
Nah,
And
he's just retarded.
Staying away from the ground.
No, he's just not mentioning a very specific setup process. It would detail it in the instruction manual. Literally, it would tell you, to set this tool up, you will level it. And it's got a bubble on it, so you can level it.
And he said rotation of the sky?
Yeah.
Oh, so not the Earth.
Regardless of where you point it.
Yeah, I heard
It
him
just
say
so
that
happens
too.
that it only creates the result you want when you've aligned it perfectly with one of the two axes of rotations in the sky. And the only
No.
way that you can have two opposing
you align it with the equatorial plane at equinox, where it does match. You're not aligning with a point of Earth rotation. You might try to conceptualize that that's what you're doing, but that's not what you've done. You've aligned it to the flat
He
plate.
said sky, didn't
And you've stepped off into the sky. That's what the device is doing. It's allowing you to transverse the grid system in the sky.
Yeah, but you'll level it to the equatorial plane to do so.
Yes.
As I say, he's
You
just not
have to.
mentioned it.
Yeah.
Opposing axis of rotations that can be found in this manner with elevation angles is if you're located on the outside of a ball. So that is going to draw this video to a close. Once again, thank you to Atlas VPN.
What did he just say?
Yeah.
Did he just say that?
Yeah, he's saying that the ball, that's the protractor that you would measure these angles through off a flat plane, is the surface that you'd measure from. Because look, my diagram shows mounts that are sideways. That's his argument. No, you still level the tool, but this is better. As far as I'm concerned, I would rather it work out this way. Yeah, okay, fine. He's made his non sequitur conclusion that, oh, it must be a ball. No, Dave, you've shown lots of examples of this tool not being level on the side of a ball. And it is fundamentally one of the steps of setting up this tool to level it. And you've ignored it. Now, when my audience share this show around and people hear what you have done, and they just go and look up, how do I set up an equatorial mount? And they just type it into Google, and it tells you to level the tool, and you haven't mentioned it. What do you think the audience is going to perceive in terms of you and how you have confronted this very distinct flat earth-proving tool when you don't mention that it needs to be leveled? You just don't mention it. You show it not level on the side of a ball and claim by non sequitur that means it proves that the protractor that you've put this mount on, that would be the angle you actually measured with the tool on a flat plane, is the tool being on the protractor. No, Dave, no. The tool has to be level. But you didn't even mention it. Oh my God. I love it. I'd rather it worked out this way, you disingenuous lying scumbag. Earth's measured flat, Dave. You damn well know it, or you'd have mentioned the levelling of the tool, wouldn't you, Dave? But you didn't. You left it out and said that the tool has to be sideways on a ball to work. No, Dave. Yeah, that's pretending that the tool is the angle it's measuring. It isn't. That was great. Anything anybody wants to add? Still got 100 people watching.
So the only time he mentioned the ground was at the end, and he referred to it as a ball. Real smart.
Yes, would like to thank you for attending the Boeing manufacturing plant tour. Now remember,
Planes don't exist.
Planes don't exist.
I'm Dave Triangles McKeegan. Remember, planes don't actually exist.
And now, our tour of Lockheed Martin.
All that needs is a laugh track. All that needs is a laugh track, and that would be the best comedy this year.
Perfect. With that, I'll say if you are watching this on either Nathan Oakley 1980 or Nathan Oakley premiering streams, then stay tuned as there will be an after show to follow. Unfortunately, though, if you are watching this live, this is where we bid you farewell. So, another massive thank you to all of you who smashed the super chat, liked, commented, shared, subscribed, joined as a Nathan Oakley 1980 channel member. There's lots and lots of material you can watch if you did want to join as a member, and all that good stuff. Of course, a massive thank you to today's Discord and G+ panels for making today's live show possible. Once again, stay tuned if you're watching on an after show. I've been Nathan Oakley, and I will see you all in the next video.
What a lovely day!